Hi, welcome to Screencast Notes 6.1. And today we're going to talk about relations and mapping diagrams. What is a relation? Well, a relation pairs inputs and outputs. So what do we know that pairs inputs and outputs? Well, we know ordered pairs. We have an X and a Y, and that's an input of X, and we get an answer Y back. A relation, besides the ordered pairs, a relation can be represented by a mapping diagram. Okay, where was I? I'm at school and the phone just rang. But a relation can be represented by either ordered pairs or by using a mapping diagram. So let's take a look at what that looks like. Ordered pairs, we've seen them many times. We have 0, 1. Remember, this is X and Y. And we have 1, 2, 2, 4. And we've all seen the ordered pairs before. Yep. And so now here's the mapping diagram. Okay, so we're going to put an input here, an output over here, and then we draw these little boxes. And so we tell the input of 0, like the one we have over here, has an output of 1. So we point the arrow and it has an output of 1. The next one, the second one, has an input of 1 and we point the arrow, it shows the output is 2. The last one, 2, is the input and we draw an arrow and it shows us that 4 is the output. And that's what a mapping diagram is. Okay, so example number 1, listing ordered pairs of relation. Let's take a look at 2. I'm going to put an input. This is A. Input. I'm sorry, I'm writing with my finger. Usually I have a little pen that helps me, so this is, I hope you can read it. My input and my output. And my input will be 1, 2, 3, 4. And for the input 1, we have an arrow to 3. Input 2, we have an arrow to 6. Input 3, we have an arrow to 9. And input 4, we have an arrow to 12. How would I represent that and list these as ordered pairs from a mapping diagram? Well, I take the input 1, and I know it's pointing to 3, so I'm going to write the 3 as my output. The next one, 2, it points to 6. 6 is the output. And then we go down the 3, 9, and 4, 12. Let's do B. B. Input and output. And let's see. Whoops, that's a little bit big. There we go. And now for the input, you know what, hold on, I want this looking pretty. And our output, and let's say we have 0 to 4, and then from the output we have 1, 0, -2, and a -3. Now, take at the input 0. The arrow points to the output 0. So that ordered pair would be 0, 0. Number 2 points to 1, but it also points to -2. So that would have two ordered pairs, 2, 1, and also 2, -2. And then the last one, 4, goes to -3, so that would be 4, -3. And that's how we list the ordered pairs of a relation. Okay, in example 2, it says determining whether relations are functions. Now, a function, let's define that. For every one input, there is exactly one output. So for every one input, there's exactly one output. So let's take a look. If I have an input-output table or a mapping diagram, and I have -9, -2, 5, and 12, and -9 points to 0, -2 to 5, 5 to 10, and also 12 is to 10. So when we do that, we just set up the ordered pairs, but we see that -9, 0, -2, 5, 5, 10, 12, 10. For every input we have exactly one output. So that is, this relation is a function. Let's look at another one. Input, another mapping diagram, output. And this time we have -2, -1, 0, 1. And here we have 3, 4, 5, 5, and 6. So from -1, the arrow points to 4. From -1, the arrow points to 3. So these ordered pairs are -2, 4, and -1, 3. Look what happens when we go to 0. When we have an input 0, we have 5 as an output. We also have 6 as an output. So that has two outputs. So that can't be a function, because a function's definition, for every one input, there is exactly one output. And this one has two outputs. We have the 5 and the 6 for 0. So that cannot be a function. So the relation is not a function. In the last example, we're going to describe the mapping diagram. And as we look at this one, 1 goes to 15, 2, 30, 345, 460, we can determine that the relation is a function. So now we could even describe that further. We can look at the pattern of inputs and outputs. What do I mean by pattern? Well, this is going up, and let's use a different shade. This is going up by +1. Each one is going up by a plus 1. Here, this is going up by a plus 15, plus 15, plus 15. So we can even describe it further and say, as each input increases by 1, the output increases, what do you think? Yep, by 15. Okay, so I'm going to stop here, but you're to do on your own, as we're done with example 1, on your own is 1 and 2, and after example 3, 3, 4, and 5, very similar to what I've just done. So we'll see you tomorrow with all your work. Good night.